Hey, if you are new here, this is Chandan and you are watching the learning field. Okay, so most of you are really appreciate me to for the short notes on complex analysis. Okay, so I am really very thankful for that. So and you request me to make the short notes on other topics also. Okay, so this video is regarding the short notes on ordinary differential equations. Okay, and so let's start. And before starting the solution, I am saying that I am skip the basics part or the solution method for the ordinary differential equations. I think you are all know that the methods to solve, how to solve the differential equation, different methods like variation of parameter and so on topics same part. Okay, so I skip that part, that is the solutions part, that is the method of solutions of ordinary differential equations part. And here in this video we are just taking the, or we are just recall the most important results and theorems on ordinary differential equation for the exam. Okay, so let's start. And before starting this video, and I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. Okay, so the first result is consider the ODE. Just a minute. So consider the ODE mod dy dx plus mod y plus a, this is equal to 0 where a belongs to R, then the number of real solutions are. Okay, so number 1 is if a equal to 0, then yx equal to 0 is the only real solution. Number 2 condition is if a greater than 0, there does not have any real solution. Number 3 is if a less than 0, there exists exactly 2 real solution. Okay, so the next result is consider the ODE mod dy dx plus mod y plus a equal to 0 where a belongs to R and yb equal to c, that is this is the IVP. Okay, then a has unique solution with yb equal to 0, that is if the initial condition for any b this is 0, then there are unique solution for all b belongs to R. Number b is has no real solution with yb equal to c for c non-zero. Okay, the next one is if a greater than 0, then there are no real solution. If a less than 0, then there are 3 conditions or 3 result. Has unique solution if yx equal to a for all ba belongs to RT, this ba means a pair. Okay, and has unique solution if yx equal to minus a for all b minus a belongs to R2, and has no real solution if for all bc belongs to R2 where c not equal to plus minus a. Okay, so this here are the number of solutions regarding the number of solution questions. Okay, now there is a note, consider the ODE dy dx equal to ky to the power alpha where yb equal to 0, kb in any constant. If b belongs to R and alpha belongs to 0 1, this alpha belongs to 0 1, then the ODE has infinitely many solutions and the solutions are linearly independent. Okay, so this is very important result, and based on this result there are many questions comes in the CSIR NET exam or any other exams. Okay, so now next one is consider the ODE a0 x dnx dny dnx dxn plus a1x, that is this is a n degree ordinary differential equation with the coefficient a0x a1x and so on. Okay, where x belongs to an interval I, and this is the non-homogeneous equation and this is the non-homogeneous part. Okay, qx where aix and qx are the continuous functions of x and a0x non-zero for all x, then there are results. The results are if y1 y2 and yn are any n solution, that is if y1 y2 or yn are n solution, since this is a differential equation with degree n, that means the differential equation has n solution. If y1 y2 or yn are solutions, then linear combination of y1 y2 and yn of this equation 1 above equation also a solution if either qx equal to 0 or summation ci equal to 1, that is the coefficient, the combination of linear coefficient of the combination of linear coefficient, combination of coefficient, this is equal to 1. Okay, and this is, that means this is the case of homogeneous equation and this is the convex combination. Suppose if we take y equal to c1 y1 plus c2 y2, okay, c2 y, then this is a solution if this c1 plus c2 this is equal to 1. Okay, this is the condition. Now fundamental set of solution. What is the fundamental set of solution? Let f1 f2 and fn are n linearly independent solutions of nth order homogeneous ordinary differential equation is called fundamental set of solution. That means if there exists or if the differential equation has 2 linearly independent solutions, then the solution set is called the fundamental set of solutions. Okay, Now the result one is, there is a result, the solution set of the nth order homogeneous linear ODE forms a vector space of dimension n. Okay, this is a very important result. Now we comes to the most important topics of ordinary differential equation, which is Wronskian. Okay, based on Wronskian, every year there exist questions in the exam. Okay, so let and you can think that in each question paper in the section OD, one questions from Wronskian or more questions from Wronskian can come. Okay, so let's y1, y2, yn are any n solutions of the differential equation 1, that means the nth order differential equation. Okay, each of which is differentiable at least n minus 1 times in AB. Then the determinant, this y1x, y2x, ynx, y1 dash x, y2 dash x, yn dash x, and this is up to n minus 1th order differentiation. Okay, so this determinant is called the Wronskian of n function and is denoted by w of y1, y2 and yn, and this is, since y is a function of x, that means w is a function of x only. Okay, so this is called the Wronskian. Okay, now the results based on Wronskian are very important results. Okay, so let's consider P0x, this is the second order differential equations. Okay, we mainly turn to the Wronskian to the second order differential equation. Okay, so mainly in the exams there are the questions from Wronskian comes which are based on the second order differential equation. Okay, so for that we go to the second order differential equation and the result on that part. Okay, so P0x plus y dash x plus P1x y dash x plus P2x y, this is equal to 0. This is a second order differential equation. Okay, where P0x not equal to 0 and Pix are continuous on x belongs to AB. Okay, then number 1 is two solutions y1 and y2 of equation, these equations are linearly independent even only Wronskian of w1 and w2 is not equal to 0 for all x belongs to AB. Okay, number 2 is the two solutions y1 and y2 are linearly dependent if and only Wronskian equal to 0 for all x belongs to AB. Okay, there is a confusion. Okay, there is a confusion, I clear that. Okay, you can have a confusion in this result. Okay, I will clear that. Okay, now note, if given that y1 and y2 are two solutions of the ODE, but the ODE is not given. Okay, this is the confusion you can ask me. Okay, and the ODE is not given. Okay, so this is a important term, if ODE is not given, but in that case we just discussed, in that case ODE is given. Okay, so if ODE is not given, then Wronskian of y1 and y2 not equal to 0, this means y1 and y2 are linearly independent. But if Wronskian of y1 and y2 are 0, then we can't say anything. Okay, so this is the confusion which we are already cleared now. Okay, so now let us come to a theorem. The Wronskian of two solutions of the equation P0 y dash double dash plus P1 y dash plus P2 y, this is equal to 0 is identically 0 or never 0 throughout the interval. Okay, so this is a very important theorem. Okay, that means if the Wronskian at any point of an interval is 0, then this is 0 throughout the interval. Okay, and if there exists a point in between, suppose there exists a point x0 in between closed interval AB. Okay, suppose this is the interval given. Okay, so if x0 belongs to AB, if Wronskian at x0 non-zero, this implies Wronskian of x is non-zero for all x belongs to closed interval AB. Okay, and if there exists a point x0 belongs to closed interval AB such that Wronskian of x0 this is equal to 0, then Wronskian of x is equal to 0 for all x belongs to closed interval AB. Okay, so this is the theorem. Now let us come to some results. If the w of x is Wronskian of y1 and y2, then wx is equal to, this is the defined for the case of two solutions of the for second order differential equation. Okay, now number 1 a, if x0 is a common 0 of y1 and y2, the results are very important. Based on this result, every year the questions can come in ODE section. Okay, so that is y1 x0 equal to 0 equal to y2 x0, then Wronskian of x equal to 0, this implies Wronskian of that is y1 and y2 are linearly dependent. Okay, the next one is if y1 and y2 are linearly independent, then they never have a common 0. Okay, number C, if x0 is a common point of extrema of y1 and y2, that is y1 dash x0 equal to 0 and y2 dash x0 equal to 0, then wx equal to 0. This implies y1 and y2 are linearly dependent. Okay. Number D is if y1 and y2 are linearly independent, then they never have a common point of extrema. Okay. E says that if x0 is a repeated 0 of y1 or y2, that is if y1 x0 equal to 0 equal to y1 dash x0, or this is the case of y2, then Wronskian equal to 0, and this implies y1 and y2 are linearly dependent. Okay. If either y1 or y2 has a repeated root, that is this implies y1 and y2 are linearly dependent. Okay. The next one is if G, if y1 and y2 are linearly independent, then neither y1 nor y2 have a repeated 0. Okay. H, if y1 and y2 are linearly independent, then there is one and only one 0 of y1 between any two consecutive zeros of y2 and vice versa. That is if this is in case of y2, then this is consecutive y1. Okay. So this is the converse part, y1. Okay. This is the vice versa part. Now I, if y1 and y2 are linearly independent and y2 0, y2 non-zero on given domain, then y1 and by y2 is monotonic. This is an important result. J, let f1 and f2 be a set of linearly independent solution of the ODE and g1 and g2 be another linearly independent solution, then Wronskian of f1 f2 is equal to constant into w Wronskian of g1 and g2. Okay. This is the results. Now Abel's formula, let us come to Abel's formula to find the Wronskian of a system of an ODE. Okay. And based on this formula, there are also the questions are also comes in the exam. Okay. So if this is the differential equation, then by Abel's formula we have to calculate Wronskian of w and w2. This is equal to a into integration minus the coefficient of y dash by coefficient of y double dash into dx. Okay. Where a being the Wronskian at the initial point. Okay. That is Wronskian of x0 y0 equal to w0. That is the value of the Wronskian at the point 0, which is will be provided in the exam. Okay. Now the result is, consider the ODE y double dash plus qx into y, this is equal to 0, where qx is less than 0. This is also a very important result. Okay. For all x belongs to and let yx be a non-trivial solution, then yx has at most 1 0. Okay. Number 2 is yx is either strictly increasing or strictly decreasing. Similarly, y dash x is either strictly increasing or strictly decreasing. And number 4 is if there exists x0 such that y dash x0 equal to 0, then limit x tends to infinity, yx equal to infinity, and if y dash at x0 is less than 0, then limit x tends to infinity, yx equal to minus of infinity. This is also a very important result. In this video, the result which I will take in this lecture, the result, each and every result are very important for any exams in which the syllabus included the ordinary differential equation. Okay. Not only for the CSIR net. Okay. These results are very important. Now the result is, let yx be a non-trivial solution of y double dash x plus qx equal to 0. That is, here the first degree differentiation term is vanished. Okay. That is, in this case y dash x equal to 0, where qx is greater than 0 for all x greater than 0, and integration 1 to infinity qx dx is less than infinity. Okay. Then yx has infinite number of zeros on positive x axis. Now you can question me that this result, how to make the questions based on this result. Okay. Suppose in the option we have given that, let this is a differential equation, and if yx as a solution is a solution, then the option says that yx has a infinite number of solutions on the positive x axis, negative x axis. Based on these types of statement, the questions can be made. Okay. So number 2 is yx is non-monotonic solution. Okay. That is, this is oscillatory solution. Okay. And number 3 is yx has infinite number of points of local extrema, that is minima or maxima. Okay. Now there is a important theorem which is called Strum comparison theorem. Okay, this theorem is also very important. I think in the year 2017 or 2018, I think one questions come based on this theorem. Okay, so let phi x and psi x be non-trivial solution, and this theorem based theorem and this result based questions is also come, I think, in the year 2018 year, 2017 year, 2016. Okay, I exactly not remember that. Okay, so now the Strum comparison theorem. Let phi x and psi x be the non-trivial solution of the equation y dash x plus px into y equal to 0. There, that is, in this equation also, this is a second degree differential equation ODE, but here also the first order term is missing. Okay, and y double dash plus qx into y is equal to 0 respectively on the interval I, where px is greater or equal to qx. Then between any two zeros of psi x, there is at least one zero of phi x. Okay, this is very important theorem. Now we come to an concept which is regular and irregular singular point. See, in this topic the questions is not generally asked in CSIR NET, but for GATE this concept is very important. But in the year 2022 there is a question based on this topic. Okay, so you can't skip it, this topic. Okay, so the first one is a point x0 is an ordinary point on the DV y dash plus px into y dash plus qx equal to 0 if both px and qx are analytic functions of x. Okay, so this is called the ordinary point. Okay, if both px and qx are analytic. Now a point x0 is called singular point of the differential equation. This same if either px or qx or both fails to be analytic at the point x0. Okay, now and here analytic means differentiability. You just check the limit, whether the limit at that point of the function exists or not. Okay, and a point x0 is regular singular point of the differential equation. This if the function x minus x0 into px and x minus x0 square into qx are analytic. Okay, otherwise x0 is said to be irregular singular point. That is, if x minus x0 into px and x minus x0 square into qx, either of these two does not exist at the point x0, then x0 is called the irregular singular point. Okay, now we have, this is also a very important topic which is stability analysis. Okay, so consider the system x dot equal to ax plus by, and this is a linear system. Okay, we also comes the case of non-linear system. Okay, so let x dot equal to this and y dot equal to this. Therefore we can write this is x dot y dot equal to so we can write x dot vector equal to a into x vector. Okay, so where the coefficient matrix A is this a b c d. Okay, this is the system. Now nature of roots, based on this topic directly questions comes in the CSIR NET. Okay, or any other exam. Okay, so nature of the roots are lambda 1 lambda 2. How to get or how to calculate the roots on this from this system, given system? So lambda square minus lambda of a plus b into lambda plus ad minus bc, this is equal to 0. We all know, or we all calculate the eigenvalues of a matrix. Okay, so I think there is no issue. Okay, so nature of the critical points. So if we get the real, unequal and same sign, the roots, okay, then the nature of the critical point is a node. Okay, and stability, whether it is stable or not, asymptotically stable if the roots are negative. Okay, and stable if the roots are positive. Okay, clear? There is no confusion, I think. Now if we get the real, unequal and opposite sign roots, okay, then the critical point is a saddle point which is unstable. Okay, and if we get real and unequal root, then we get a node again, and this is asymptotically stable if roots are negative, otherwise stable. Okay, now if we get purely imaginary, that is if the real part of the complex root is missing, that is if we get only iota and suppose this is a. Okay, if this is a root, this type of roots, then this we get a center and stable but not asymptotically. Okay, now if we get conjugate complex but not purely imaginary, that is a plus minus iota b format, if we get, and in this case we get this real part is missing, then we get spiral point and unstable if the real part of roots are positive. That is, if this is the roots is a plus iota b, then if a less than 0, then it is unstable, real stable, or if we get a greater than 0, then this is unstable, this is stable. Okay, now it comes to an important result, which is results on finding the integral by in complementary function by inspection. Okay, so this is a method. I say that I skip all the methods, but I think this is a very important inspection. Okay, so that I take it in this discussion. Okay, so let d square y plus px dy plus qx y equal to 0, then if number a is y equal to x is a solution if p plus x q equal to 0. Okay, number b is y equal to x square is a solution if 2 plus 2px plus qx square this is equal to 0. Number c is if y equal to e to the power x is a solution if 1 plus p plus q equal to 0. Y equal to e to the power minus x is a solution if 1 minus p plus q equal to 0. E y equal to e to the power mx is a solution if m square plus mp plus q equal to 0. Y equal to x to the power m is a part of CF if m into m minus 1 plus pmx plus q into x square this is equal to 0. Okay, in these results based one question is comes recently, I think in 2020 or 2022. Okay, I think in 2020. Okay, so in the recent year, based on these results, one questions come in the exam. Now convert the non-linear system, okay, to the linear for check the stability. Okay, suppose x dot equal to we discuss for the linear case ax plus by and cx plus dy for x dot equal to x dot and y dot this is equal to, okay, and in this case suppose these are the non-linear function. Okay, px and qx are the non-linear terms. Okay, so to find the coefficient matrix at the given critical point, and the critical point is already provided in the exam. Okay, so suppose the critical point is ab, so how can we find or how can we get the coefficient matrix from the non-linear terms? Okay, there are another formula to get this to convert the non-linear system to linear system, but here I take another formula. Okay, I use here another formula, and I think this is the easy formula. Okay, so we just calculate this matrix del p del x del p del y del q del x del q del y at the point ab and get the matrix, and then we just the same as above. Okay, that is we then calculate the lambda 1 and lambda 2 the eigenvalues, okay, or the characteristic values. Okay, and then the same process. Okay, now let us take these questions, okay, which is comes in 2018 December section. The critical point 0 0 for the system. See, this is a non-linear system. Okay, there are the 4 options given. So we take px equal to this and qx equal to this. So we calculate px, qx, py, qy. That is the partial differentiation with respect to x and y of the function a, p and q. Okay, this is the partial differentiation terms, and we calculate at this point 0 0. So we just get this. So this is the coefficient matrix. Okay, this is suppose a. Therefore we just calculate the lambda characteristic values, and we get characteristic values. This is the real unequal root. That means we get a this is saddle point over. Okay, this is saddle point. Okay, see the above formulas or the table to get the solution, proper solution. Okay, so now we comes to another important concept, which is ellipsis condition. Okay, so let fxy be the function defined on D, then f is said to satisfy the ellipsis condition on the if there exists k belongs to z plus such that mod of f x y1 minus f x y2 less equal to k into mod of y1 minus y2 for all x y1 and x y2 belongs to D. That is the ellipsis condition in the variable on the variable y only. Okay, and k is called the ellipsis conditions. Okay, now we comes to an theorem based on ellipsis constant. If f is the f be a real valued function defined on D, okay, D equal to xy, so this is an interval or rectangle type of region you can say. Okay, so this is D such that del f del y mod del f del y exists and mod del f del y bounded then F satisfies the ellipsis condition on D with the ellipsis constant K. Okay, and now we comes to an important theorem, existence and uniqueness theorem. Let us consider the IVP dy dx equal to fxy, y at x0 equal to y0. If f is continuous in a rectangle R, this is the rectangle suppose, and satisfying the ellipsis condition on R, the ellipsis condition we just saying above, then there exists a unique solution y equal to yx on the interval I such that mod of x minus x0 is equal to h of the IVP, where h equal to minimum of a comma b by m, and m is the maximum of mod fxy in R. And this from this theorem, this is also known as Picard existence and uniqueness theorem. Okay, and based on this theorem the questions are also comes in the exams. Okay, this is also an important exam. So now it comes to the method of solving the system of ODE. Okay, so this is an important concept. Okay, so see the concept and learn. Okay, so let us consider the system of ODE y dash equal to ay. If lambda is the eigenvalue of a and c equal to c1 c2 be the eigenvalue corresponding to the lambda, then the solution is written as in the form yx equal to c e to the power lambda x. This is equal to c1 e to the power lambda 1x and c2 e to the power lambda 2x if the system is based on two variable. Okay, so now there is three cases. Okay, case 1 is if lambda 1 is not equal to lambda 2, then u1 equal to and two variable and for the second order. Okay, so u1 equal to this and u2 equal to this are the eigenvectors corresponding to lambda 1 and lambda 2. Then y1x equal to this u1 e to the power lambda 1x and y2 equal to u2 e to the power lambda 2x are two linearly independent solution, and the general solution is as written in the form yx equal to c1x c1 y1 plus c2 y2. Okay, now case 2, if lambda 1 equal to lambda 2 equal to lambda and gm of 2 equal to lambda, then we know that gm means what? Gm means the dimension of the eigenspace. That means corresponding to an eigenvalue, the eigenvector, number of eigenvector corresponding to the eigenspace in the eigenspace. Okay, so y1x equal to this and y2x equal to this, then this is the general solution, the same case. And now case 3 is very important one. If y1x equal to y2x equal to lambda and gm equal to 1, that is there is only one eigenvector in the eigenspace corresponding to an eigenvalue lambda, then there exists one eigenvector in the eigenspace. Let u1 be the eigenvector, then another eigenvector u2 is given by u1 equal to m minus lambda iota into u2. Okay, this is the eigenvalue lambda. So we get u1 and u2. So y1x equal to this and y2 equal to this, then general solution is c1 y1 plus c2 y2. Okay, now it comes to the boundary value problem. This is also a very important concept. So px y dash plus qx y dash plus rxy equal to sx, boundary points. Suppose these are the boundary points, and this a is called the regular boundary condition. a0 ya plus a1 y dash equal to c1, b0 yb plus b1 y dash b, this is equal to c2. Suppose this is called the regular boundary condition, and this type of boundary condition ya equal to yb and y dash equal to y dash b are the regular boundary condition. Okay, sorry, this is periodic boundary condition. Sorry, made a mistake here. Periodic boundary condition. Okay, now it comes to Strum-Liouville problem. Okay, based on this concept, in 2022 there is a exam. Okay, there is a questions which I try to solve in my videos of the ODE solution of 2022. Okay, so a second order linear differential equation is of the form ddx of px dy dx plus qx plus lambda rx into y equal to 0, where px qx rx are the real functions such that px has continuous derivative and qx and rx are continuous on this interval px greater than 0 and rx greater than 0 for all x belongs to ab, lambda being a parameter. So this is called the Strum-Liouville problem, and we all read the Strum-Liouville problem where in the BSc mathematics. Okay, in which chapter we calculate the eigenvalues and eigenvectors for the case of lambda greater than 0, lambda less than 0 and lambda equal to 0. Okay, so that chapter, and you must solve the questions of the chapter. Okay, so these are very important, and here so I skip that part to that is the calculation of lambda, the calculation of eigenvalues and eigenvector. I think you all know that part. Okay, so that I skip that part and I take here the important result based on the SLP. Okay, so one is all eigenvalues of SLP are real, eigenvalues of SLP are countable, eigenfunctions of corresponding to different eigenvalues are linearly independent. If this a to integration a to b fg, this is equal to 0, okay, on this, and here I did not take any variable, or I am not taking any variable, okay. So why? You can comment me in the comment section below, because I am not write any dx or dt in this part, okay. So why? You can comment me in the comment section below, okay. So then fg are orthogonal, okay. This is a fun fact, okay. So every second order ODE can be retained as in SLP. Each characteristic function of phi n corresponding to the characteristic value lambda n has exactly n minus 1 zeros in AB. So this is very important result, okay, n minus 1 zeros. Now I think this one, okay. See, now the G is the characteristic function corresponding to the different characteristic values of SLP are orthogonal on the given interval, okay. Now let us comes to the important concept one, which is Benediction criteria. The full Benediction criteria, Deluxe theorem and Poincare Benediction theorem are all available in my channel, okay. So you can check for your if you want to learn the complete concept with the example, okay, because in December 2019 a questions comes in the from Benediction criteria, okay, and there is no questions comes in from Poincare Benediction theorem, but maybe there is come some questions from Poincare Benediction theorem or Deluxe criterion also. So you can check for that, check the criterion in my channel, okay. So let us come to the point. So let second order autonomous dynamical system is defined as, suppose this x dot equal to fxy and y dash equal to gxy. Let D be the simply connected domain in R to such that divergence of f equal to del f del x plus del g del y. If it is not identically equal to 0 over any subdomain of D and does not change its sign over D, under this condition it does not contain any non-trivial periodic solution. That is, this is the theorem, and in the 2019 December section, one question, one option is like this: no closed trajectories inside D, okay. This is all we are also can say, okay. So this is the end of the ODE, okay. Maybe there are some important result may be missing, okay. I can miss any important result, you can say that, or you can comment me in the comment section below, so that this is important but this is missed out, okay. So thank you, a big thank you for watching these videos, and if you like the content, then please give a subscribe, give a like to this video, share it with your friends and subscribe the channel. Thank you, see you again in the next video, okay, bye bye.